Hello everyone, I am Manav, and in this video we are going to learn about the carbon and its compound. So without wasting any time, let's begin with our topic. As we know that carbon is mainly everywhere. If I used to tell you that carbon is a non-metal and it comes on 6th number on the periodic table, mean it has 6 electrons. The electronic configuration for what is this? Carbon is 2,4, mean 2 electron in K shell and 4 electron in L shell. So this thing is what? Nothing but electronic configuration. And valency of the carbon. If you want get that valency of the carbon. So you'll have to make a formula. It is a very simple formula. If it has 4, so it cannot give 4 or gain 4. So its valency is neither in it does not have any charge on it. It is simply 4. Electronic configuration is simply 4. And if I used to talk about the carbon, mean where we found carbon. So our body is also a little bit made up of carbon. Pencil tip is also made up of carbon. Diamond, most hardest, strongest natural material in the world, is also made up of carbon. And after that, our coal is also made up of carbon. So mainly most of the things are made up of carbon. So let's learn about the occurrence of the carbon. And yes, before understanding this, I would like to say that symbol for carbon is a very simple symbol. You can easily remember this. It is not like Na, sodium is from S, and in the chemistry it is Na. It is not like that. The symbol of the carbon is just C. Just C. I'm right? So let's begin. 2. The occurrence of the carbon. Carbon is found in simple form in itself, its free form we can say, and it is also found in combined form. In combined form. In combined form. Now, what is this combined form? Combined form, we can say the carbon is making, sometimes carbon makes what we say, this covalent bonds or compounds. At that time it is mixed chemically with the other element, with the other metal, non-metal, with the other materials, and at that time it is known as combined state. It is not fully pure state of the carbon, but in our free state it is pure and pure. If I am talking about its free state, so I can talk about coal, I can talk about graphite, I can talk about uh, about the diamond, most expensive. I'm right. So this is what all are examples, and in free state it is pure. It is as possible. It is fully pure, but in the combined state, it is combined up. It's make compound, and the formation of compound lead to like mixtures we can take, and they mixtures, or we can say compound, are impure. We can take example of carbon dioxide. Carbon dioxide, CO2. Oxygen plus carbon is equal to carbon dioxide. Here, at that particular time, at that particular time, sometime when we bonds, when the base and the acids are mixed up, when they are mixed up, there is formation of neutralization reaction. There is formation of neutralization reaction, and that neutralization reaction also form carbon dioxide, or we can take example of air pollution. Here is also carbon dioxide, there is also carbon dioxide. 0.03% in our air atmosphere, this free atmosphere, is present carbon dioxide. And now one question arises that what is aptotropes? I think it is aptotropes of carbon. No, I will say that I didn't get this question. Rather, I didn't knew this question. From where I'm getting this? So now that I am going to announce, or that I'm going to make you understand, please listen me carefully, because it is too much and too much important. Now, our what we can say this yes, aptropes of carbon mean, or aptropes of an element. It means that in how many other physical state that element is present on Earth, not on Mars. So carbon, the isotopes of carbon are of two types. They are categorized into two categories: crystalline, and there was another. I'm not getting that word in my tip, but I can remember. I'm not Amorphous, yes, I got it. Amorphous and crystalline. Now you will say, what do you mean by crystalline? What do you mean by amorphous? So crystalline means I was saying that crystalline mean a substance or a solid shape that has its atom or molecule in a proper distance. Mean they are uniform and the uniform distance, and they have uniform their size, they have uniform everything. And in our amorphous, we can take example of powder. It does not have its proper shape, its chemical compound, its chemical, what we say this, its atom, or we can say its atom, or we can say that molecule are arranged in a non-uniform manner. This is what amorphous and our crystalline. In our crystalline we have coal, not coal. It was a very long word, I think. Yes, it was a very long word. Bitter fluorium, like this. And we have our diamond, and also graphite. So some people used to say that if coal is also made up of carbon, and diamond is also made up of carbon. So why? Why the our diamond is too much expensive? Does you got this question? If yes, so I would like to say that there are also other things. There are some physical property there is difference in the physical property of coal. It is very soft, but our diamond is too much hardest natural material. All right. So let's learn about diamond. We know that diamond is hardest natural material of this nature. After that, diamond is insulator and a bad conductor of electricity. And when it's melt, on a high temperature, it release or it produce CO2, carbon dioxide. Now you will say, how to find whether it is producing carbon dioxide or not? If you will take or not, if you have the calcium carbonate water like this, there is a water, so it will turn to milky if there is presence of carbon dioxide. Or you can take the candle. Our carbon dioxide is not a supporter of fire, so that candle will stop burning. So these are some experiments. And yes, we were on carbon. Now you will say, how? Why this is not a good conductor of electricity? For this, you'll have to understand about the structure of carbon of the diamond, and that structure is nothing but it is like when we say that is like this. It is like a mountain. It is like a castle, like this. So they are bonded. They have a covalent bond structure and each and every atom is bound to other. So there is no electron that is free, and if there is no free electron, so how electricity is possible? Sorry for this. I'm right. So this is what a very good point. Now let's move on to the graphite. If I talk about graphite, so graphite is also a very good crystalline carbon, a type of carbon. And if you want to learn more, so we can tell you that it is slippery because the structure of the carbon is not like this. It is like a hexagon or a pentagon. They are joined and there are many layers of the carbon. So due to that there is a force. I'm not getting the name of that force, Manav force, like this. So due to that force, they used to do like this. So it is slippery and it is soft, a little soft. That's why it is used in pencil for good apsara writing. I'm right. And after that we have got the structure. Yes, graphite is a good conductor. Now you will say how? Because when they are the structure, if you will look out of the structure of the graphite, so one electron are free. So those free electrons help that there is a space, and due to that there are free electrons, and that free electrons help them to revolve, we can say, or to conduct electricity. Now let's move on to our coal, or we can say there is another name. It is very long name, I'm not getting that name. So the structure of that thing, coal, is like it is like a ball structure. Soccer, you must have seen real soccer. First there are pentagons in which black color is colored. There are some other chains like that structure. So I hope, friend, you understand our today's topic. And before leaving this video, I would like to say that carbon make they have a